So this video discusses about the superposition principle in two dimension. So I beg before this lesson just have to go through actually a superposition principle in one dimension. That is the lesson that you have to go for before you go for this, because it is a sort of continuation. So humble yourself, go for that before you go for this. Otherwise, let's start. What is a superposition principle in a two dimension? So now the emphasis here is that we have the charges in a two dimension instead of having the charges in one dimension. So for this point, you should have to remember about the concept of vectors, and basically a vector resolution, and the net vector as well as, I should say, the net vector as well as the direction. I would say the net vector as well as the direction. So that concept will be very prominent as far as the superposition principle in a two dimension is actually concerned. Let's say we have the charges in two dimension. Let's say this is the charge. I should say this is actually x-axis, and let's say this is the y-axis. We can have that. And let's say we have a charge here given as charge 1, and let's say it is given as the negative charge, and let's say we have another charge here given as charge 2, and let's say it is given as the positive charge, and let's say there is another charge here, let's say given as, should be a charge 3, let's say it is given as the negative charge, and there is another charge here, let's say given as the charge 4, let's say it is given as the negative charge. Now these actually charges are in two dimension, and much as we have, let's say we should have another charge here, let's say given as a charge 5, let me call it as a positive charge. So much as we have some charges in our x-axis and others in y-axis, that is in a two dimension, or even if we can have another charge here, that is still more two dimension aspect. So principle remains the same on the net actually a force. Now what is the net force, let's say acting on, let's say, a charge 1 and due to the other charges? So in a two dimension is basically different a bit with one dimension, because in two dimension you just have to be required just to add the actually the forces we have. That is in the expression rather, we have F12 plus F13 plus F14 and plus F15. So there's no need of looking at whether it is positive or negative, otherwise components themselves will tell whether it will be negative or positive as we'll be resolving. So direction of the vector, actually the direction of the force, which is a vector, will be the one that will be required whenever we'll be determining the direction of the components of these forces. So in two dimension, just have to add the forces literally in the expression as it is here. And the next from there, which to have to solve for F1 2 and F1 3, F1 3 and F14 and also F15 using the Coulomb's law. That's how you start to get it. Now let's go into the system and see how we can make it up. F12, it is the force between the charge 1, I should say F12, it is the force between the charge 1 and the charge 2, which is between the two charges here. So what is the separation distance between the charges? Either you can be given or you can be required to find those charges on your own. Now what is the direction of, let's say, F12? Now these actually charges are unlike charges, and F12 will move towards this direction. I should say it will be attractive, so it will be towards this direction. That is the direction of F12. So that is, upon calculating F12 using the Coulomb's law, then you'll be required to resolve F12 into components. So F12 as a vector, may have it here. So F12 as a vector will be resolved into components. We'll have F12x, that is I, plus F12y, that is j. And this will happen upon calculating what is F12, F13 and sort of things. Then you go into the actual analysis upon you go into the detailed analysis by resolving the vectors forces into components. That is that. Then you go for, as you can see, this is the direction of the force F12. It is towards the positive direction. Upon resolving, you see that F1x will be the same as the force F12. I should say F2, actually F12 as the component of, actually you see that the x component of the force F12 will be the same as F12, since the force is along x-axis towards the positive direction. And the y component will be given as well, because this actual force has no component along y-axis. So we'll have that as well at the end of the day. Then we'll go for F13. So F13 as well will be resolved using the Coulomb's law. Will be solved using the Coulomb's law. What is the F1? Actually F13. So it is between these two. And F13, these charges are right charges, and the force charge 1 will experience will be repulsive force, and it will be towards this direction. And this is F13, and you'll be required to resolve that into components by expressing two-dimensional coordinate system there. So this is how it will be. So this will be given as the x component, this will be given as the y component, and the directions will be that. And this is the angle that we'll be using to actually to resolve F13 into components. Always your drawings should be smart, and that gives you the clear picture as well. So how should we have this angle? And basically you can calculate this angle using the trigonometric ratios, much as you have this test, you have this distance or this distance. And also sometimes you can be given this distance and this distance without this distance. You can be able to find this distance using Pythagoras theorem. That is in case if this distance has been given, also this one has been given, but this one has not been given. So the distance that can be used to find actually F13 is given as this distance. This is the separation distance between the charge 3 as well as the charge 1. In case it is not being given, you can be able to calculate that using Pythagoras theorem if you have this as well as this. But this angle can be calculated using the trigonometric ratios, and it is the same as this angle. Vertical opposite angles are the same. Then upon having that one, then what are the components of the force F13? You'll be able to have F13 as a vector. Then you have X components as well as the Y components. Now you see that the X component, it is downwards. So since it is down, it will be given as the negative F13 X. That is I. And the Y I should say, sorry for that, but this is Y component. This is Y component, and this is X component. So you see that the X component, it is going towards this direction. So since it is negative, then it will be given as the negative there. It will be given as a negative here. Let me use another ink here. You should know it. We'll have a negative there. And that is like that. And the Y component, it is downwards. It will also be negative. So make sure that you understand about the vector solution. We'll have it as a negative as well. Negative F13, actually F13Y. That will be as J. And also do the same with F15. Principle remains the same. So for for F15, the point of interest is that, let me take out whatever to see. You know, this is charge 1 negative, like that. Now F15, now it is between the charge 1 as well as the charge 5. Now these charges are unlike charges, and the direction of the force F15 will be towards this charge. So which means now in this case the force will be in this direction. That is F15, and this is the angle that will be used to resolve the force into components. So this will be given as the Y component, and this will be given as the X component. And we can be able to find this force, actually that angle, using the trigonometric ratios. If we have this one and also this one, we can be able to have this angle. And mind you, this distance can be calculated using Pythagoras theorem if we have this as well as this, so that we can be able to calculate what is F15 using the Coulomb's law as expression distance. So these are just some of the things you have to bear in mind whenever you're thinking about superposition principle in 2 dimension. Then you'll be required to resolve F1 actually 5 into components. So F15 will be given as, now the X component is going towards the positive direction. That will be given as a positive. We'll have F15X I, and the minus Y component is going downwards. We'll have F15, YJ. We'll have that. And likewise, we'll also do the same with F14. So F14, it is between a charge 1 and a charge 4. And the charges are like charges, so the force will go towards this direction. That will be negative. That will be towards the negative direction. So F14 as a vector will be given as, now since the force is acting horizontally towards the negative X direction, we'll have negative F14xi, of which we know that the magnitude of this one will be the same as actually F14. It will be the same force. Anyway, plus F14 yj. So that's how it will be. Then next we are going to have F1 net x, meaning summation of forces on a charge 1 along x-axis due to the other charges. So have F12x I plus F13x I plus F14 actually x. Of course, we should also have F15. That should be that. We already done that one. So we have F14x I plus, we should also have F15x. So sum up these actually components as the x components. And the next we'll have F1 net y. That is the summation of forces acting on a charge 1 along y-axis due to the other charges. So have F1 2y, that is j, plus F should be 2, I should say F13, y j plus F14 y j plus F15 y j. Then upon having that, what I'm going to do is we'll now have the net force, since we have x as well as the y component. So the net force, no, before you go for the net force, now what is the net force in vector notation on charge 1 due to the other charges? Will be given as F1 net x I plus F1 net y, that is j. This will be the net force in unit vector notation. And now what is the magnitude of for the actually a net force? So a magnitude of the net force will be given as F1 net in general will be given as the square root of F1 net x square plus F1 net y square. And how about the direction? Will be given as the tan inverse of F1 net y divided by F1 net x. That's how we learn things in a superposition principle in a 2-dimension. So just have to be conversant with the vectors, then you'll be safe. Let's just have to appreciate how we can handle this using what we have highlighted here. Let's say we have a 2-dimension coordinate system. Let's say this is the case, and we have this is charge 1, which is a negative charge. It is given as 2.5, let's say coulomb. And let's say this is a charge, let's say 3, should be charge 2, a positive charge, given as, let's say 1.5 coulomb. And let's say we have another charge here given as a charge 3, and that is given as the positive charge. It is given as, let's say 2 coulomb, rather should be given as 2 coulomb. And let's say we should have another charge here given as, let's say a charge 4. It is given as, let's say 4.7 coulomb. Let's say we should have it in that way. I'm saying this is 2 coulomb, rather should be that. And let's say the separation distance here is given as 2 meters, this is 3 meters, and let's say this is 4 meters. Now, what is the net force and the direction acting on charge 1 due to the other charges? So principle remains the same. Since this is two-dimensional, the expression will just be literally expressed as F1 net. F1 net will just be given as F12 plus F13 plus F14. That will be the expression. Then we are going to use the Coulomb's law in order to find what is F12. What is F12? It is the force between a charge 1 as well as the charge 2. So this is the charge 1, then this is the charge 2. And this is the separation distance between the two charges. And we don't know what is this separation distance. But what we have here is a right angled triangle. We have this as well as this, actually as well as that. We're going to use the Pythagoras theorem in order to have this separation distance. So what would be that using the Pythagoras theorem? What would be that using Pythagoras theorem? So we'll have it as a 9 plus a 16 is equal to r square, and the r square will be given as the square root of what is 9 plus 16? 9 plus 16, that will be given as 25, and the square root of 25 is given as 5. So which means this which means this separation distance is given as 5 meters. So that would be that. And then we are going to calculate what is F12. That is, we have it as 8.99 times 10 to the power positive 9, like that. And what is charge actually 1? We have it as 2.5. And what is charge 2? We have it as 1.5 divided by 25. Since this is 5 meters, to the power 2 is given 25. So we have 8.99 times 10 to the power should be negative positive 9. Let me have this. 8.99 times 10 to the power positive 9, and it times 2.5, and that times 1.5, and we'll have that then divide by 25. That will be given as the very largest actual force, that is given as 134 134 should be 134.8 5 about 5 cells. 1 2 3 4 5. That is neurons, and I'll keep it safe there. But let me have it in a scientific notation, because it seems to be something very inaccurate. So we have it as 1.34 should be 35 times 10 to the power positive 9 neurons. That is F13. Actually should be F12. 1.35 times 10 to the power positive 9 neurons. Then let's go ahead and calculate what is F13. What is F13? Principle remains the same. It is between actually a charge 1, I would say it is between charge 1 and charge 3, and which is between these two guys. Using the Coulomb's law, we have F13 being given as 8.99 times 10 to the power positive 9. And what is the charge 1? We have it as 2.5. And what is charge 3? We have it as, should be 3.4. That is 2 Coulomb lather, should be that. And divide by what's the separation distance? We have it as 4, which is the same as 16. And now we have 9 point, should be 8.99 times 10. 8.99 should be in brackets. 8.99 times 10 to the power should be positive 9, and it times 2.5 and times 2, and that is that. Then divide by, should be 16. That is the same as, now F13 being given as 2 point, we'll have it as 810 newtons. I should say times 10 to the power positive 9 newtons. That is F13. So that is F13, 2.10. Just have to say times 10 to the power positive 9 newtons. So care has to be critically considered whenever we are dealing with these actually calculations. And let's go ahead and calculate what is F13. So F13, it is the force between, I should say F14, not 3. So F14, principle remains the same. That is 8.99 times 10 to the power 9. And what is the charge? I'd say, what is a charge? Now we are looking for F14. Now what is the charge actually F4? We have it as 4.7 times what is charge 1, 2.5. Divide by what's the separation distance? That is, we have it as 6 meters. So 6 to the power 2, we have it as 36. So run the process again. That is 8.99 times 10 to the power, and that should be positive 9 times. We have 4.7 and the times 2.5. That should be that. And I will have it as F14. That will be given as 1.056 times 10 to the power should be 11 newtons. That is the value of, should be F14. That is 0.56 times 10 to the power 11 newtons. We'll have that. So take your time during the calculations. You should not have to rush, because you may end up having something wrong. Of course it involves a lot, but just have to be cool and do things accordingly. Now we have managed to find these actual forces. Now what is remaining is to resolve the forces into components. So we'll have F1x, actually F12, we need its x component as well as the y component. We are on F12, we need the x component, F12x, xi, we need that one, and f12 xj, we need that one, and also f1 should be 3, we need x component as well as the y component. So f13 xi, we need that, and f13 and f13 yj, we need that one as well, and we need f14 also its components. We need f14x, that is I, and also f14y, that is j. We need all these components in that case. So how should we now resolve the forces in the components? So first thing, you should have to understand that come up with the expression. The next, solve for the forces using the Coulomb's law. The next, we should have to resolve the forces to components. So let's start with F12. F12, it is the force between charge 1 as well as the charge 2. These are guys. And what will be the direction of, where will the direction of the force being emanated from? Will be from charge 1. That much we know. And the two charges, this is a positive and this is the negative, and the force will be attractive force. So which means for the charge 1, we'll experience the force towards this direction. So this is the direction of the force F12. So that will be the direction of the force F12. And this is the angle that will be used to resolve the force F12 into components. And this force will be calculated using the trigonometric ratios. Much as we have this as well as this, we'll be able to calculate this force into components. That will have y component going like that, and x component going in that way. So this will be positive, this will be negative. As you'll be substituting, you should have to understand that. And those negatives, you put those on your own, but on a calculator you just have to punch what is this angle, whatever, then times the force itself. If it is negative, it is a humble duty to put that one as a negative, looking at the direction of the vector. So again, make sure that you have the full knowledge on the vector resolution. So in case you are not aware about the vector resolution, you just have to go through my video playlist to come across the vector resolution concept, and you learn from there. So x component of this vector will go towards this direction, and the y component will go towards this direction, and this is the angle which is against the x-axis. You can be able to resolve that, and you see that the x component will be given as the negative force. So you substitute here and also substitute here as well. And let's also go for F13. So it is the force between a charge 1 as well as the charge 3. So we have charge 1 and this is the charge 3. And these are the actual charges in this case. And the force has to be from charge 1. Now this force, actually these charges are negative charges, and the force between them, it is attractive force. And this force, actually this charge will feel the force being attracted towards this direction. So how should we resolve this force? So you see that this force is acting along x-axis towards the negative direction. So which means the x component of this force, which is given us that, will just be negative F13, and the y component will be 0 because the force has no component along y-axis. And also you do the same with this one as well. And at the end of the day, you sum up those components along axis. That corresponds to have it as F1 net x, and also do the same with F1 net y, and you do the everything as I already explained in the previous, actually in the recent analysis of the superposition principle in two dimension. That's how you should applicate it. So you need to understand much about the concept of the vector resolution, because it is the one that has been greatly used. So thank you.